Hello and welcome to a special edition of CIB in Conversation, which features one of our keynote speakers for World Building Congress 2022. Let me first say a big thank you to all our sponsors for supporting the Congress, and we are very, very grateful indeed for that support. I'm Don Ward, I'm Chief Executive of CIB. Today I'm pleased to welcome James Baker. Hello, James.
Hello.
Great to have you here. I see you're in Manchester in the UK. Please introduce yourself. What's your current role and involvement in the world of research and innovation in our sector?
So I'm James Baker. I'm the Chief Executive of Graphene at Manchester. That's part of the University of Manchester in the UK. So it's part of our university network, but I'm not an academic. My role is really around accelerating the commercialization of graphene products and applications into the marketplace.
And we're going to talk a lot more about graphene because that's what you're going to talk about at World Building Congress. But before we do so, you said you're not an academic. So tell me a little bit more about your background and your career. How have you got to where you are today?
Yeah, so my career has been very much in industry, 25 years in industry, predominantly aerospace and defense. So working for BAE Systems, so everything from aircraft to submarines to cyber intelligence. And the last 10 years or so at BAE Systems, I was involved in technology. So that was taking technology from the various laboratories into the products and applications. And that's when I came across graphene. I was doing a piece of work on futures with the main board of BAE Systems, looking about how technology might impact what we did in the future. And that's when graphene came along. And then shortly after that, I found myself joining the University of Manchester in this role, looking at the commercialization of graphene.
And how long have you been there now?
Gosh, I've been here nearly 8 years now. Eight years when I first joined. Graphene's still very young, 2004, sticky tape and graphite. You can all try this at home. You can isolate a single atomic layer of carbon. So what is graphene? It's got length, it's got breadth, but at one atomic layer thick, it's the thinnest possible material. So I joined about 2013, and yeah, I've been here nearly 8 years now, and it's been a great journey since those first years.
So tell us a little bit about that journey. You know, so some of the early highlights perhaps in the first 2 or 3 years. I mean, we'll have plenty of people at the Congress and watching this interview who will be early in their career, thinking about some of the milestones that they might be able to anticipate in the future. What are some of your highlights?
So the big challenge we're trying to face with any advanced materials is it can take many tens of years from discovery through to first appearing in products and applications in everyday life. Carbon fiber, often we talk around for aircraft, for cars, for buildings, is probably 60 years old now, but it's only just starting to find its way into everyday top-end aircraft, cars, etc. So with graphene, one of the challenges, I mentioned I'm not an academic, you know, today there are over 100 other two-dimensional materials now being studied. The science is looking about the future, making these stacks or layers of multifunctional material. So some great science, some great activity taking place. But my role is really about how do we turn those concepts, those ideas into our products of the future, whether it's lightweight aircraft, longer lasting batteries, or when we get into construction, new building materials that are more sustainable, less CO2 footprint, and hopefully have a better level of performance. So in terms of highlights, you know, the journey started with the creation of what we call the National Graphene Institute, which is a facility in Manchester that brings together that great science from across the university, brings the physics together with the material science, together with the engineering. And then probably more importantly, the second building that we've also constructed is the Graphene Engineering Innovation Centre, or the GEEK. And the GEEK is very much around the translation of that science into these products and applications. So highlights, already graphene 17 years young, so it's still quite young as a new material, but you can now buy graphene shoes, graphene tires, graphene paints. I'm going to talk a little bit at the conference, particularly around some of the construction technologies like concrete. By adding a very, very small amount of graphene into concrete, we can get equivalent performance using 30% less material and no need for any metal rebar, just to give you one example where it can have a real impact around sustainability, but also in support of some of our construction and built environment targets and challenges.
And whilst we're talking about concrete then, and how far away would you say that could be from first commercial application, let alone, you know, a commercial rollout?
So that's probably one of the themes of why I'm coming to the keynote, really, that lots of great science, but if we do things traditionally, it can take many years, if not tens of years, for certification and regulation. Over the last 4 months in the UK, we've poured over 800 tons of concrete. We've done a concrete gymnasium, we've done a roller skating ring, we've done a housing development, and we've done a road or a lay-by. It's part of what I call the living laboratory. So in parallel to doing all the testing, all the research and the development and samples, we're also undertaking what I call real life engineering pours. So this is a proper engineering slab. So if I use the roller skate example, I think it's 54 meters by 15 meters. If you're in Manchester over the winter or in the summer, you can currently go ice skating on the slab, and in the summer you'll be able to go roller skating. So again, a real engineered slab that's suspended on the first floor, and again, no metal rebar in that pour, and also a reduction in CO2 overall for that complete concrete slab. So quite a lot of activity, but if we're going to take this to market, still some time to do to get the certification, the regulation, the approval. We're not building high-rise buildings, we're not building bridges, we're not building roofs at the moment. It's more of a managed approach, if you like, to get that certification and approval in different applications. And
clearly in those pilot projects, if I might call them that, tell us a little bit about how you've been able to collaborate then with industry as well as those sorts of regulators, and any sort of tips, I suppose, or any highlights from that experience.
Yeah, sure. So we're part of the university, and a university doesn't want to be a supply chain. So our business model is working with industry. So the GEEK partners with industry. We partner with large corporations. We partner with small, medium enterprises, SMEs. We also create and support a whole range of spin-outs and spin-ins from the University of Manchester, but also from outside. So we trying to build what I call the ecosystem or supply chain of companies. So on construction, it's quite a good story, really. That, gosh, 2.5 years ago, we do a number of conferences. I was speaking at a conference, and a couple of ex-Manchester University alumni were at the event. We had a conversation with them. We do have a program of work that works specifically with small businesses across Greater Manchester. So this wasn't one of your large construction companies. It was an SME. It's a company called Nationwide Engineering. You know, 2 partners who set up a business. They do rail, they do housing, they do services for construction. And in 2.5 years, we initially teamed up with them, did an initial feasibility study. We bid for some funding out of what's called Innovate UK, which gives you grants to accelerate technology. And in 2.5 years, we've gone from an early concept, a brainstorm, a meeting, and through the GEEK, we've actually developed a formulation for adding to concrete. And again, this has been a key part of the program. This isn't a group of scientists in white coats adding a little bit of graphene in a lab and taking that into the industry. From day one, we've designed a process that can be added as any other additive at the batching plant. So there's no new equipment, no new facility, no new techniques that are needed. It's just another additive that can be added at the batching plant, and then the concrete pours just like any other concrete. So for me, that's been really key from day one, that we've worked with industry, we've worked with a supply chain. We can use any graphene in the solution. So that's another unique solution. We don't have a particular brand of graphene. We can take graphene from the supply chain and we can use that, which will be key if we roll this out, because we want to have a supply chain that's in the UK, it's in Europe, it's around the world. So we want a solution that can use the different types of graphene that exist around the world. So for me, it's an evolving case study. We've done 800 tons of concrete, but we're starting to build that supply chain, and we're doing it in a way that the construction industry can take benefit and use in real world. My silly analogy is we can't have a scientist with a white coat adding the graphene. You have a guy with a shovel and a spade and a hose pipe, and we have to be consistent with how concrete is used and poured in the construction industry. So that's been key to our approach going forward.
So, I mean, how easy have you found it to bring together the white coats and the shovels, as it were, or what have you had any particular challenges in that respect?
So yeah, there's always challenges. We have a model that for me is quite unique. I call it around a make or break model. You know, often when we come for an innovation cycle, the white coats can spend months or even years coming up with designs or concepts. They then make something and then it doesn't work, and you go through that whole cycle again of months and years. So the innovation cycle can take a long time. Whereas our cycle is really, we bring together academia, the white coats, with industry, the builders. You know, we bring the science, the equipment for graphene, for mixing and formulating graphene, for testing that, for understanding how that graphene might mix. The industry bring together their knowledge of engineering, of construction, of how we actually need to do a concrete floor. That's not knowledge that we have. I'm not a building specialist. So they bring that together. But then the make or break model is how to do that rapid design, make and validation. If it works, repeat that and continue, or if it fails, fail fast, learn and move on very quickly. So that's enabled us to do a much more aggressive, if you like, approach. And as I mentioned, over the last 3-4 months, I can't believe we've poured 800 tons of concrete, but it sounds a lot of concrete, but it's actually quite a relatively small amount of graphene. Because again, quite interestingly, you have to add as little as 0.01% graphene to make a difference. So again, a very small amount of graphene makes a large difference. So again, I'm sure this is of interest to the people at the conference. Sometimes when we do something that's sustainable, it costs more, or there's a compromise. With graphene in concrete, the overall cost of the slab typically is lower than without the graphene, because we're using less material, because there's no steel rebar, there's less material cost. Also, quite interestingly, and I'm sure this is relevant to many of the listeners, to achieve what typically can take up to 28 days cure time, through the addition of graphene, we're achieving the 28-day strength within 12 hours. So that means we're actually getting concrete that cures much quicker, so you can actually use that floor much more shorter timescales than traditionally it takes before you can do further on operations. So again, as well as the prime benefits of less material, tougher, we're also getting additional benefits like cure time, fewer cracks, less expansion joints. So again, we're seeing some real benefits through the addition of graphene and advanced materials into the construction sector, but we're learning as we go along, and we need to further develop those going forward. By the time we get to the summer of the conference, I'm sure we'll have more data. We're talking to aircraft, runways, taxiways. So again, I'm sure we'll have even more examples to talk around in June when we come to the conference.
And sorry, can I just ask a stupid question? How much is graphene per gram, or you know, is it? I presume it's getting cheaper and cheaper to manufacture now as one gets to volume.
It is. So there's no one type of graphene. Typically, we're talking here about platelets. So this is small flakes or small layers of graphene, and price is coming down. You can still pay a very large amount for graphene if you use sticky tape and pencil. But today there are a number of suppliers who can produce graphene by the ton, by the 10 ton, up to 100 ton plus in some areas. Again, many of them have got REACH registration in Europe. So that's the approval to make that volume of material. And costs can range from $50 a kilo up to several $100s a kilo for a reasonable quality graphene material. The key point, as I mentioned earlier, though, is we're adding a very small amount.
Yes.
So the delta cost is there, and that cost is coming down, but the overall cost of the slab typically is lower depending on the specification and the slab and all the other costs you need to take into account.
And yes, and you did mention it earlier. And I think one could have predicted that one would expect a lower cost slab, a thinner slab, less volume and so on. And therein would be some of the sustainability materials benefit. But was something like the reduction in cure time, was that unexpected, or was that going to be clear from the chemistry?
Yeah, not unexpected. So graphene has the properties that we often refer to them as multifunctional. So my background, aircraft, if I use an analogy there, you might start off around mechanical strength. Can I actually make my wing thinner using less material to make it lighter, less fuel, lower emissions, longer range? It's also got thermal management properties. So can I now de-ice my wing by taking the heat from the engine to spread around the engine wing? You continue beyond that around electrical conductivity. Can I make it into a Faraday cage to replace the copper? Can I also make it into energy storage, where actually as the air flows over the wing, I can actually store that energy in my wing? So graphene has this fantastic multifunctional properties. That's why we're talking around concrete a lot today, but we can also talk about longer lasting, quicker charging batteries. We can talk about printable sensors or inks. So again, in the built environment, potentially we're going to have walls in the future that have insulation, but they also have heating. They also maybe have sensors in them that can control lighting or heat or make them functional. So Graphene Advanced Materials has a real role around this, if you like, smart materials. So tuning the material to your particular application. But yeah, there's lots of case studies out there at the moment where, in particular, you might start off with mechanical strength, but if you also add in thermal management, you get these dual or secondary properties that are real benefit to the market. The challenge to the people here is, how do we design our aircraft or our houses of the future using the features of these new materials? And I think that's probably one of the subjects to bring out. How do we really start to embrace, I think I did a blog and we called it Graphene's Ready. How do we get the architects, how do we get the designers really understanding the benefits of these advanced materials in the way we might produce our construction or our built environment in the future?
And do you have any thoughts on how to answer that question? How do we engage more designers and indeed other parts of the supply chain in these developments?
It's part of the reason why I'm coming to the conference. For me, what we really need to do is get some of these case studies out to see. So the 800 tons of concrete so far, for me, that suggests that we're not at commercialization, because that's still relatively a small amount of concrete. If I was talking about 800 grams or 8 kilograms, I wouldn't be very credible probably at the conference. So for me, getting these case studies out there, actually seeing the data, this approach to innovation, we call it the Manchester model, producing these living labs. I won't show them now. I'm wearing graphene training shoes. At the entrance to the Geek, we have recycled rubber mats. So again, we're working with a company called Space Blue, who take a scrap tire, chop the tire up. Normally you get a very poor performing rubber crumb for your flooring or your matting in your gymnasium or your doormat. But through the addition of graphene, you get a very high performing product. Again, we've tested it as an example, and it's 1/3 thinner, but 5 times stronger than a traditional recycled rubber mat through the addition of graphene. So again, recycling is probably a key theme. If we can get people through sustainability now to embrace concrete or rubber or construction or batteries, energy storage, for me, sustainability is probably one of the drives that are really getting people to engage now. And by telling some of these stories, by engaging with the supply chain, for me, we can accelerate the adoption of graphene into the market.
James, that's fantastic, and I think attendees at the conference will be fascinated to hear about the latest developments. How would you sell attendance at the conference then to come and hear you speak and meet you during the breakout sessions and so on?
I think the power of a conference is bringing people from different backgrounds. I'm not a construction specialist, but what we bring is quite a breadth of experience around advanced materials. We're talking a lot about graphene, but it doesn't have to be graphene. I mentioned there's over 100 2D materials. Not for the technical audience, we're going to go into molybdenum disulfide, MXenes. So there's a whole family of these advanced materials coming along in places like Manchester. Manchester's also invested in the infrastructure, the GEEK, the NGI. We also have a Royce Advanced Materials Institute, but we've developed a model to engage with industry. So for me, the benefits of the conference is it brings together this multidisciplinary background and approach to see how we might build collaborations in the future. A number of our partners are from Australia. There's quite an emerging supply chain in Australia around graphene. So there is an indigenous supply of that material. It is on a global basis. At the end of the day, graphene is carbon. So it's in the air, it's in the ground, it's in your body. So for me, how do we take this material and really make a difference for areas like built environment? And sustainability is probably the other key drive. How do we actually really move towards net zero through our aircraft, through our cars, through our batteries, through our buildings in the future? So hopefully we'll bring together some people, but collaboration for me is really what we're looking to achieve through attending events like this one in June.
James, fantastic. I have no doubt that your keynote will be one of the highlights of World Building Congress 2022. Just before we finish, I like to ask all our guests what you would see as the top opportunity or perhaps the top challenge for politicians and policymakers in your field or industry practitioners that perhaps people should be taking away from your keynote. Yeah,
so I touched a little bit that we're doing some great science, we're doing living labs, we're really accelerating product, but it still takes a long time to get certification, approval, regulation. So one of my areas that I'm really trying to lobby, certainly in the UK, and I guess it's lessons learned from the global pandemic with the vaccine. For me, what happened with the vaccine was incredible performance. I don't believe any shortcuts were taken, but with the right approach from government, policymakers, we can get the right people together to really accelerate the adoption of a new material or a new vaccine in this case. So I'd like to see similar taking place around graphene. If I take concrete as the example, how do we get the right people in a room to really adopt and embrace this new material? Don't take shortcuts. We still need to do the work. We still need to get the approvals. But if we get the right people in the room, we can do that in a much more aggressive timescale than it would traditionally take. So for me, I'd encourage policymakers, end users, cities, to really embrace this. In Manchester, we've made some real progress working with the city to see how we accelerate some of these. It's not about risk, it's about a managed approach to outcomes. So for me, if we can think of an outcome that's more sustainable, that's got benefits towards net zero, and we get the right stakeholders in the room, then I think we can really accelerate this as a solution into the market. So that for me is one of the key areas we need to do better. But for me, it's not shortcuts, it's doing things in a different way to certification and approval.
Well, on that note, James, thank you so much indeed for this conversation today. And I look forward hugely to seeing you in Melbourne, well, fingers crossed, in Melbourne in June 2022. As I said, I'm sure James will be one of the highlights when he gives his keynote speech at the Congress. James, thank you very much indeed.
Thank you.
For more information on the World Building Congress 2022, please see the dedicated website via cibworld.org. It should be appearing on the screen right now. Thank you so much for watching this special edition of CIB in Conversation. And as I said, we look forward to seeing James and as many of you as possible in June 2022 for the World Building Congress. Goodbye for now.